Okay, all right, take two. So today, based on what we learned yesterday when we defined what a function is, somewhat, okay, it's gonna take some time for you guys to completely figure out what a function is. We're gonna move ahead a little bit and talk about, well, okay, if that's the definition of a function, then what's not a function, okay? As a matter of fact, I would think that sometimes, with this topic, the what's not a function is just as important as knowing what the definition of a function is. Okay. So yep, and there are two ways to do it. Okay, two ways. All right. So let's go ahead and do that right now. Okay. All right. So like I said in the introduction, okay, over the next 3 days, we're going to talk about what's a function and what's not. Okay, so the first 2 days, we're gonna look at this by table, all right? And then the last day, we're gonna look at it by graph, which is super duper easy, okay? So today, all right, on the first day, I wanna get across to you what a function is more specifically than yesterday, and then what would not make it a function. So today is very much a conceptual understanding. Tomorrow, you'll practice with Regents questions on that particular topic, and then on the third day we're going to look at it by graph, all right, which doesn't even involve drawing anything. Okay, so it's super duper easy. Okay, now one of the things I want to get back to is the analogy that I gave in the last lesson, which is something like, okay, if you were to put a bunch of kiwis into a juicer or a blender, right, what do you expect to like come out of the juicer? Yeah, kiwi juice, right? And then if you put an apple into a juicer, what do you expect to come out of the juicer? Yeah, apple juice, right? And then if you put oranges, right? Orange juice, right? It's the same thing. So in other words, if you were to put, oranges into a machine, you don't expect to have a apple juice, right? So let me write that out. Okay, so let's say, right, we got three things. We got a kiwi, right? We got oranges, and we got apples, right? If you, the expectation is, if you have a kiwi, right? You put a bunch of kiwis, you expect to get kiwi juice, right? I just use KJ, kiwi juice, right? If you have oranges, you expect to have, right, orange juice, right? And then if you have apples in your blender, you expect to get apple juice, right? Now, with that said, all right, hold on, I gotta press pause real quick. Okay, all right, so where was I? Okay, so with that said, right, hold on, the lights just turned off. Now, with that said, you can't possibly put kiwi in your juicer and expect to get orange juice, right? So what happens, right? I mean, think about it in this situation. What happens if you put like kiwis in your blender and sometimes it gives you kiwi juice and sometimes it gives you orange juice? Like you wouldn't want that. Like you want to know what kind of juice you're getting from your fruit, right? So, or your machine, right? What happens if you have a faulty machine that does that? So you don't want that. So knowing that a function, again, the age-old analogy as a machine, you don't want that. So that's what makes it a function, does not make it a function, all right? In very layman terms, you cannot put something into the machine and have two different outcomes. Then that defeats the purpose of having a machine, right? Like, so for example, if you walk into a light bulb factory, you don't expect to see like sweaters, like, in their factory store, right? Same thing. So with that said, right, one of the things that you will be required to know is, if I were to give you a table like this, would you be able to tell whether this set of numbers represents a function or does it not represent a function? So is it a function or not? Okay, so let's just say, right, here we have the domain and range. So domain, range, all right, otherwise known as x and y, right? So I'm not doing anything crazy here, right? So this is just x and y, right? We got 2, right? So if I put 2 in the machine, I expect I'm going to get 3 back, okay? Whatever that machine does, I don't care right now, okay? And if I put 5 in there, I'm gonna get 6, right? If I get 4, I'm gonna get 10. And if I put 1, I'm gonna get 20, right? So far so good, right? Because each machine, right? This machine specifically, right? Each time I put a number in there, I get a unique result, right? So that's what these arrows are saying, right? I get a very unique result, all right? So this is a function. All right, because it's a machine that does what it's supposed to do, okay? Now, look at this one, right? Here we have x and y again, right? Input, output, right? So again, I'm just using these words interchangeably just so that you get used to them, okay? Now, if I put 10 in, I get 15, right? That's what these arrows are for. If I put 20, I get 45, okay? That's fine, all right? Because I don't know what the machine does or does not do, all right? All I need to know is that it's a machine. So 30, right? If I put in 30 in the machine, I get 25 out, right? And if I put 40 in the machine, right? And it spits out 35, right? So far, so good, right? Each one of these, I get a unique result, right? Because only by putting in 10 can I get a 15. Only by putting in a 20 can I get a 45, so on and so forth, right? Now, let's take a look at this last one. So this is, yes, this is a function, okay? Look at this last one, right? Now, let's test it out. So we got input, output again. Right, input x, output y, right? Domain range, same thing, right? I'm just listing them all now. So look at this machine, right? Watch this. If I put 2 in, I can get 20. Okay, fine. But look, there's another arrow. So if I put 2 in, I could get a 40. All right, so things are looking kind of wonky, right? If I put in 4, I can also get a 40. And if I put in a 3, I'll get a 30. So here's the problem then, all right? Big problem. I don't know, right? If I put something into this function machine, right? If I put 2 in, I might get 20. If I put 2 in, I might get 40. That's not good. That's unpredictable, okay? And in math, you know, unpredictability right now is not good, right? Because you have a certain set of expectations. When you do something, you expect a very specific set of results, right? And this doesn't meet that criteria. So no, this is not a function, okay? All right, so now I know that you guys probably want to write something into your notebook, and you will be smart to do so, all right? So write this down, okay? Actually, write these two down, okay? So take a moment. All right, press pause if you have to right now. Copy this down, okay? So the rule is the x cannot repeat if it is a function, okay? So I actually have to add that in when I finish doing this rule. All right, the input or the domain or the independent variable, right, cannot repeat if it is a function, okay? So notice how, right? This didn't repeat. It was unique. 2, 5, 4, 1, right? 10, 20, 30, 40, right? And they all had unique outputs also, right? Whereas this one, look, I had to write 2 twice, right? I had to write 2, 20, and then 2, 40, right? That's not a function, all right? So that's a very kind of like a quick and dirty way of knowing what's a function and what's not, okay? So write this down. Now, here's the second part, all right? In more specific language, because in the regions, if someone were to show you this table, right, in a part 2, right, and they ask you this as a question, right, and you can say no, and this is all you have to say, right? Each element of the range, right, that's y, has to pair with exactly one element of the domain, which is x, okay? And you can say each element of y is paired with exactly each element of x, okay? You can say that. And then you can say for dependent variable, independent variable, all that, okay? All right? So got that? Now, I don't have to explain why anymore because I said it in the beginning, right? Because a function is a very specific set of rules. And what's the rule again? It's right here. This is the rule. This is the rule that all functions follow, okay? The input cannot repeat, okay? The x cannot repeat. So that's what that is, okay? Let me see how I'm doing on time. Yeah, I'm almost there, okay? So again, if you got questions, feel free to email me, find me in the after school help on the conceptual one, and I'll see if I can find more analogies to explain to you, okay? Or you can ask me that during class, because you're probably not the only one with more questions, okay? I might present this in class also, I don't know, okay? All right, now, here's the last analogy of the day, all right? And hopefully with this understanding, you'll really remember what a function is or is not, or what is or is not a function, okay? And then tomorrow we'll do some practice, okay? So here's the analogy. Now, I'm a big Lakers fan, okay? I just want to get this out there, all right? There's nothing Mr. Ng loves more than the Lakers, the 49ers, the Sevilla soccer team in Spain, and the country of Brazil, and the city of Sevilla, all right? There's nothing that I love more than all those things. So, let's say, right? Now, this was very interesting. I actually did a Google search, and I pulled up a box score because I want to make the point, right, on this as an analogy. And I just typed in my favorite Laker team of all time, the 1987-88 Laker team. Is it even 87? I don't think they didn't win the championship that year, actually. Okay, all right. Now, I actually just pulled up a box score, 1988 LA Lakers box score, and this showed up, and this points out my analogy perfectly. Okay, so here, this was a game from January 2nd in 1988. All right, so that was when I was exactly 10 years old. All right, and so this was the game, right? They played. All right, the Lakers beat the Trailblazers. All right, as usual. And so this is the box score. So when people look at the newspapers, right, in the sports section, they will give you a box score. So it tells you who played, all right, how many points they got, how many assists, how many rebounds, all that stuff, okay? So in this case, right, so the four best players, right, Magic Johnson, so let's see, I hope you can see this. Magic Johnson scored 11 points, right? So what I'm going to do is I'm just going to draw an arrow. So Magic Johnson scored 11 points, right? Now, the second best player in the team, possibly, is Kareem Abdul-Jabbar, and he scored 13 points. All right, so this is Kareem. All right, and he scored 13 points. All right, so the third best player in the team is James Worthy, actually. All right, and he scored 11 points. And then lastly, all right, the fourth best player in the team is actually, oh my God, did I just do this? All right, oh yeah, I couldn't find a picture of Byron Scott. Okay, all right, the fifth best player in the team is Michael Cooper, right? And he scored 2 points, right? All right, he's a defensive specialist. He's not much of a scorer. All right, can't really shoot either. All right, okay, so right now, look at this, right? If I were to list this, so Magic Johnson, right? I'm going to write it like a coordinate, okay? Magic Johnson scored 11 points, right? Kareem Abdul-Jabbar scored 13. And then James Worthy scored 11. And then Michael Cooper scored 2, right? So here's the question. Is this a function? Right? Think about it. What do you think? Is this a function or is it not a function? Think about that. Right? Think about the definition I've given you today. Yeah, it's a function, right? Because look, none of these guys, right? None of the x variable repeated, right? It's Magic Johnson, Kareem Abdul-Jabbar, James Worthy, and Michael Cooper, right? None of these repeated. Now, can they repeat the points? Yeah, of course. Like what? Like there's no rule in basketball that says like different players cannot score the same amount of points. Like that's a ridiculous rule, right? So as you can see, now I would use yellow because those are the colors, but then you can't see it. All right, as you can see, Magic score 11 and James Worthy score 11. and that's okay. Like they're not breaking the rules. But what's a problem is if I were to say Magic Johnson score 11 points, but then Magic Johnson also score 12 points, right? Because if you look at that, you'd be like, huh? Wait, what? Like how does he score like 11 points and then 12 points in the same game? Now he could score 12 points in the next game, right? But he can't score 11 and 12 in the same game. Like, you can't have Magic play 2 games within the game, right? During the game, okay? So that would not be a function, right? If I had listed this, then this would not be a function because it's technically impossible, right, for Magic to score 11 points and then score 12 points, all right, in the same game, okay? By the way, the credit for this analogy goes to Mr. Cohen. Okay, all right, just want to say that. Okay, so that's it. All right, that's the lesson today. So again, if you look at a function, right, what's the rule? Very simply, the input value, x, cannot repeat, okay? And tomorrow I'm going to show you some strategies on how to make sure you always follow this rule, okay? All right, that was a very lengthy explanation because I have a lot of ideas going on in my head of how to present this. So, all right, let me stop. All right, thanks for watching. Have a good day, and I'll see you tomorrow. Bye.
OMG, that was so good.